If you want to have a better understanding of how PPO works in the context of LLMs, this video will provide a general visualization of how things work under the hood. So let's start off with the models that are required for PPO. So first we start off with the reference model. So this is the original LLM that we're going to train with reinforcement learning. And for initialization, we will create our policy model, which is just a copy of the reference model. Similarly, we would have a reward model that is trained with preference samples. And to create the value model, we will also just make a copy of the reward model. So now let's go through step by step exactly what is happening. So typically, we will have some data samples which provides us with prompts. And from this, we can initially pass this to the policy model to generate a set of responses. So this is called the rollouts. So this is within the outer loop of the PPO before we do the optimization. So we run the policy to get some rollouts. So now we want to compute the advantages with regards to these rollouts. So this is the compute the advantage estimates. So the way that we do it is we will have a rollout which is a pair of the prompt and the response. And now we can pass this directly into the reward model to get a single reward value. And to get per token reward values, the way that we do it is to calculate the KL divergence between the policy model probabilities and the reference model probabilities. So this will give us individual token level KL values, and we add the reward to the last token. So this will give us the individual reward value. At the same time, we pass in our prompt and response to the value model, and the difference between the reward model and the value model is that for the value model, the value head is applied on every output token. So now we will have a per token value, and when we get both the per token values and both the per token rewards, we can calculate the generalized advantage estimation value, which will give us advantages for every token. So if you want to know more about generalized advantage estimation, you can refer to one of my previous videos where we did a whiteboard derivation of it. So now that we have the advantages, we can now compute the cost function and use AutoGrad to get the policy gradients. So we want to do this optimization of the policy model. So the way that we can do it is first we sample mini batches. So previously we had rollouts and we computed the advantages. We sample a mini batch, so we also get a few samples and the advantages. And now for each of this sequence, we compute the importance sampling ratio. So the importance sampling ratio is just the probabilities of the policy model divided by that of the reference model. And then with that we get importance sampling ratios, and we do some clipping. So this will create some form of trust region so that we don't update the policy too much and destabilize the training. And then lastly, we multiply this by the advantage, and then we take the negative average over tokens and sequences in the mini batch, and this will be the loss for our policy model. And then we can do gradient descent to update the policy model. We also have to update the value model. So there are two models being updated. One is the policy and the value model. So the way that the value model is being updated is we used the predicted values as that of the prediction, and then to get the ground truth values so that we can compute a loss, which is the mean square error, we take the advantages that was computed by the generalized advantage estimation, and then we add the values that were derived from the previous old value model. So this would help us recover the Q value, and these will be the targets for the value model. So this is the predicted and this is the ground truth, and from there we can take a mean square error as our loss. So to summarize, this is our overall PPO pipeline. First, we have the reference model and the policy model that we want to train. So for initialization, the policy model will just be a copy of the reference model, but this will get updated. Then we want to generate rollouts, so we pass in inputs and we generate outputs. For these outputs, we will score them with a reward model, and we will add them with the KL divergence between the policy and the reference model to get the individual token rewards. Next, we will also pass the outputs to the value model to get value scores. From here, we can calculate the generalized advantage estimate, and we will get per token advantage scores. So these per token advantages can be used to update the policy by either performing gradient descent, where we scale the advantages with the important link sampling ratio, or to compute the original value model, where we can recover Q values by taking the advantages plus the O values, and this can be set as the target to update the value model. So with this, we have the overall PPO pipeline, where we show how we can use this pipeline to update both the policy model and value model to finally train a model to perform well in the task that we're interested in. Yeah, this is the overall pipeline, and hope you enjoyed the video.